Welcome back, guys. Today we will be covering Python programming basics in addition to Python programming for penetration testers and cybersecurity specialists. This video will cover 2 rooms from TryHackMe that revolve around these subjects. We will go over the tasks, explain the concepts, and solve the questions. Let's get started.
So we will be using the code editor on the right to execute the Python code. And as you can see here, we have the output that we're going to examine. And we have other files as well, shipping, Bitcoin, which we will be talking about later down the road. Okay, so we're going to start with the script from here. So here the first line we have print learn security with TryHackMe. If we execute this, we get the statement learn with TryHackMe. All right, so let's proceed with the tasks first. Task 2, we are required to just print the hello world. So we're going to leave the print statement here and replace learn with TryHackMe with the statement hello world. Going to execute this will give you the flag for this task. Right, on to the next task, mathematical operators. So the mathematical operators, we have around 5 or 4 tasks or 4 questions. The first question, in the code editor, print the result of 2143. What is the flag? Now, to answer this question, we're going to do it the simple and easy way. There are many ways to do that, including the use of variables. But we're not going to use variables because we assume that you are new to Python, okay? There is a way to answer this question without the use of variables assignment. So what we're going to do, we're going to use the print again, but we're going to cancel the double quotes. And from here, we're going to insert the mathematical operation. In our case here, it is an addition. So it is the 21 plus 43. So 21 plus 43. And if you run the code, we get the answer, which is 64. Now, we'd be asking, how can print executes a mathematical operation? Basically, since we canceled the double quotes here, we're just telling the print that we are dealing with a non-string. Okay, so basically this is non-string. It doesn't have double quotes. And Python will interpret whatever inside the parentheses depending on the mathematical operator. So here we used plus as a mathematical operator, and we put these inside parentheses. So Python first will execute whatever inside the parentheses, and then it will execute print. That's why it worked. Print the result of 42 minus 52. So similarly, we replace 21 with 142 and 43 with 52. Replace mathematical, the addition with subtraction, and execute. And now you get the next flag, and this is the output. Print the result of 10, 342. So we multiply 10 with 342. Similarly here, we just plug in the numbers and the appropriate mathematical operator, and we let Python execute. So we have 3420, and that is the flag. Print the result of 5 squared. What is the flag? So here we're talking about the exponential. So 5 squared is 5 exponential. So 5 multiplied 2 times, and we run this code, we get 25. So here you can find the reference for this mathematical operation. So it is an exponent. 5 exponent 2, 25. It's like multiplying 5 with itself. So this is the flag, and that's the answer for this task. Task 4, here we get to know the variables and data types. Okay, on to the questions. In the code editor, create a variable called height and set its initial value to 200. So height equal to 200. Okay, on a new line, add 50 to the height variable. So again, height equal height plus 50. This will add 50 to the existing value of height, which is 200. On another new line, print out the value of height. What is the flag that appears? So simply here we print height. Remember here that we are printing the value of the variable height. Therefore, we want the integer value of height. So we do not use double quotes here because we are not printing height as a string or as a word. We're printing height, we're printing the value of height. So run, and we get 250 as well as the flag for this task. Task 5. In task 5, we get to know the logical and Boolean operators. But there is no answers to, or there's no questions to cover here. So we're going to cover these concepts when we get to task 6. Here we write a program that calculates the customer basket. So here we go to shipping, and we can see the code or the statement basically. And next we have the variables. After the variables, this is where our code goes. So in this exercise, we will code a small application that calculates and outputs the shipping cost for a customer based on how much they have spent. In the code editor, click on the shipping tab and follow the instructions to complete the task. Once you have written the application, the code editor's shipping tab, a flag will appear, which is the answer to this question. All right, let's go over the problem statement here. In this project, you create a program that calculates the total cost of a customer's shopping basket. So basically, when you go to an e-commerce site, you go on and add items to your basket. The program here will track your shopping experience and calculate how much you have actually accumulated in cost when you were adding the items in your basket. So the program here calculates the total cost of a customer's shopping basket, including shipping. If a customer So here we have an if statement. If a customer spends over 100, they get free shipping. If a customer spends less than 100, meaning the total sum of all the items in their basket is less than 100, the shipping cost is $1.20 per kilogram of the basket's weight. So if the total cost or the total sum of the customer's items is less than 100, we are imposing a shipping cost on the customer equals to 100 or so to $1.20 per kilogram of basket's weight. Lastly, we print the customer's total basket cost, including shipping, to complete this exercise. So we're given here the customer basket cost, $34, and the customer basket weight in kilograms, 44 kilograms. Write an if statement here to calculate the total cost. All right, so if, and here we have the customer basket cost. We're gonna copy this. First, see if the value of the customer basket cost is more than 100 bucks. And we end the if statement with a colon. Then don't forget to pay attention to the indentation here. As you can see, there is a space, there is a distance between indentation between the start of the code block in the if statement and the actual start of the if statement itself. Print. All right, so if the customer basket cost is more than $100, we are actually telling the customer that they got free shipping. So we print here free shipping. However, if the customer basket cost is less than 100, we are imposing a shipping cost. Now, the shipping cost, if imposed, it will raise the customer basket cost. It will include shipping cost. So the customer actually has to pay the shipping cost in this case. Therefore, we have a new calculation here. Therefore, if this condition is matched, meaning that the customer basket cost is less than $100. Therefore, we have now a new condition to talk about. So else, we use else here. Okay, now the else will include the shipping equal $1.20 times the customer basket cost. Let's go back to the problem statement. If the customer spends less than $100, the shipping cost is $1.20 per kilogram of the basket weight. So we're multiplying 1.20, okay, by the customer basket cost. The customer basket cost here, the customer basket weight, sorry. So weight is 44. So 44 kilograms multiplied by 1.20. This will give us the cost of the shipping. And next we add the total. Total will be the shipping that we have calculated plus the customer basket cost, which is $34 in this case. And lastly, we print the total. And here we have total is 86.8. This will give you the flag of the second question. Next, in the last question, on line 12, where we control the customer basket cost, change the customer basket cost variable to 101 and rerun your code. You will get a flag if the total cost is correct based on your code. So if you change this to 101, what's going to happen? We got free shipping, and that's expected because here now the customer basket cost is more than 100. So what's going to happen? This code or this block will be executed in the if statement. Else will be ignored because In our case here, one condition is matched. Print the actual customer basket cost back to the user. So we're going to have this over here. And therefore here we get your flag. All right, on to the next task. In the next task, we handle loops. In Python, we have while and for loops. Let's see what we have. On the code editor, click back on the script tab and code a loop that outputs every number from 0 to 15. Right, that's very basic. So we're going to have a for loop here, and then we have a counter. In our case, it's I. You can use whatever you want. In, and the function range, which will handle the iteration from the value of I until the last value in the parentheses. So here we have 50, going to use 51. Okay, so it will start at I and ends with the value inside range -1. So let's say it's X here. What's going to happen here? The for loop will start at I and ends with X -1. Okay, it's not going to reach the value X. Remember this. That's why here, instead of 50, we put 51 inside the range function. And then we have an indentation here. Print I, and then I equal I plus 1. Through every iteration, we print the value of I back to the user, and we increment I with 1. Therefore, with every iteration of the for loop, the value of I will be increased by 1 until it reaches 50. Once it reaches 50, it's going to end the for loop. Run. Bad input on line 2. So we have to define the value of I here. I could be equal to 0. And there's this, the column, and now we have all the values printed back to the user. As you can see, it starts with 0, the value of I, and ends with 50. You could also change the value of I to start from 5 if you want, and this will change the loop or change the output. Okay, on to the next question. Task 8, we handle the functions, and we built a project to calculate the value of the amount of in dollars to the USD. It's like a conversion between USD Bitcoin conversion code. Let's go through the problem statement. You have invested in Bitcoin and you want to write a program that tells you when the value of Bitcoin falls below a particular value in dollars. In the code editor, click on the Bitcoin tab, write a function called Bitcoin to USD with two parameters. First, the Bitcoin amount. This is the amount in Bitcoin that you have. It could be 1, it could be 4, it could be 5, it could be 100 Bitcoin. And the other parameter to the function Bitcoin to USD is Bitcoin value USD. It's the value of Bitcoin in USD. So basically, this is the market value. Now, today's date is 10/11/2024, and if we check the Bitcoin to dollar, you can see. So 1 Bitcoin equals to approximately $79,000. So that's the value we have to use here. So the Bitcoin value USD is this value. It's the current value of the Bitcoin in the market. The function should return USD underscore value, okay, which is your Bitcoin value in USD. To calculate this in the function, you times Bitcoin amount variable by Bitcoin value. This is straightforward, straight currency conversion. And then the start of the function should look like this. This is the function. Here we define a function in Python. We use the keyword def or define to define a function. This is the function name. And these are the parameters that will be passed on to the function. We have first the Bitcoin amount. This is the amount we've got in the investment. And then Bitcoin value in USD, which is the amount in market, which is 78,000. Once you have written the Bitcoin to USD function, use it to calculate the value of your Bitcoin in USD. So first we have to write a code block to calculate the USD value of the Bitcoin amount we have got in the investment. So investment in Bitcoin here is 1.2. This assumes that you've got 1.2 Bitcoin. And Bitcoin to USD is 40,000. We're going to leave this value as is, although it's not up to date, but we're going to leave it because we want to get the flag at the end. Write a function to calculate Bitcoin to USD. That's the first part of the solution. going to write a function to calculate how much we have Bitcoin in USD. So define, and we have the name over here. Define the function is Bitcoin to USD. And then this function takes two arguments. First one is Bitcoin amount, and the other one is the Bitcoin value USD. Okay, at the end of the function, we end the definition with a comma. Okay, so total equal. We are told that to calculate the amount in USD, we're gonna have to multiply the Bitcoin amount we've got, which is here, multiplied by the Bitcoin value in USD. And then we want to return this. We use return total. So why return? Because when we call this function later down the road in the Python code, when we call the function, we will want the result of this call to be the amount we have calculated, the total. That's why we use return, to return the value when the function is called. Okay, so now we have calculated how much Bitcoin we have in USD. Next, one Bitcoin is now worth $24,000. In the code editor in the line 14, update the Bitcoin value to USD to 24,000. I'm gonna update this to 24,000, despite this is not up to date, but we're gonna have to comply with this statement to get the flag and see if your Python program recognizes that your investment is below the 30,000 threshold. The next part of the story here is we want the program to tell us when our Bitcoin value in USD is below $30,000. When it is, we want the program to alert us, telling us that now the Bitcoin amount we have is worth below $30,000. This is useful if you are trading in Bitcoin and you want to monitor your investment. When it falls below a certain value, you get an alert, and you use Python to accomplish just that. So here we're going to say flag equal to Bitcoin, or we're going to call the function, and pass on the values. So when we call a function, okay, we have to pass the values of the arguments. Remember that the function takes two arguments, Bitcoin amount and the Bitcoin value in USD. So we can have, to call the function, we have to pass these two values here in the function code. The Bitcoin amount, okay, is 1.2. So we pass 1.2, and then we pass the Bitcoin value in USD. The Bitcoin value in USD here happens to be 24,000. So we pass this, and then we use an if statement. Now, since we have called the Bitcoin USD, it's going to return the total. Total is the Bitcoin amount multiplied by the Bitcoin value in USD. We store this in a variable named flag. We're going now to use this flag, or to use the variable flag, in an if statement. In the if statement, we're going to compare here. If flag is less than $30,000, right? When this is the case, we want to alert the investors or the trader. Print alert, you started to lose money. Otherwise, else if. Now there is else and there is else if. We use else if we have more than two conditions. Okay, so else if the total, or the flag, in this case, equal to 30,000, we print this is not an alert because it's still in bar with the expectations of the market. So we just print everything is fine, everything looks normal. And lastly, we use else, and inside else we print you started. Let's see here. If it's less than 30,000, so here you started to make money. So why is that? Because here we're assuming that if the flag is not less than 30,000 and doesn't equal 30,000, then it means it is more than $30,000, which means the amount in USD that we've got in the investment is more than $30,000, which means the trader here is gaining money. So now what happens? The market value has increased. It's a $78,000. So 1 Bitcoin equals to $78,000. So when we multiply 78,000 with 1.2, which is the amount in Bitcoin we've got, we get the total here. And now the total is more than, or it is worth more than $30,000. So this code block of the if will be executed. If you print now, if you run the code, you see we started to make money. We've got this. And this is the flag. And lastly, we've got the files in this task. Let's go over this last task. We still have another one, task 10. In the code editor, write a Python code to read the flag. What is the flag in this file? So we go back to the script here. And now you write a code to read a simple file. So to read a simple file in Python, we actually use the open function. And the open function takes more than one method. It takes read, it takes write. It depends on the operation. In our case here, we are just reading a file, which is flag. So here we use file equal open. Inside open, first we have two arguments. The first one is the file we are reading, flag text. Since we are reading the file, we use R. Okay, this is opening the file in read mode, and print file.read. So here, after we use the file variable to read through every single line of the flag file, we actually print these lines using the file.read method. And that's the flag. Imports. Imports is when you use Python libraries using the keyword import. We're going to talk about this when we start the Python for penetration testers room.
Now that we have finished talking about Python basics, it's time now to start covering Python for penetration testers.
Okay, task 2, subdomain enumeration. And we have the script directly from here, and we have two questions to answer. All right, so let's go to the virtual machine, namely the attack box. And what I did here, I have copied the code into a new and stored it in a new file named subdomain enumeration. If you take a look at the file, take a look at the script, subdomain enumeration. That's the script. The script here is supposed to enumerate subdomains. Let's go over the script line by line. So here we import two libraries, requests and system. Next, we have a new variable named sublist. In the sublist, we read a file, subdomains. The file here is the word list that we have got. Okay, the word list consists of possible and potential subdomains that we believe might exist on the target. So we store all of these possible subdomains in a file named subdomains, and we use open with the method read to go through these subdomains line by line. Next, we split the lines using split lines, and we store the output again under a new variable named subdoms. We open a for loop. In the for loop, we have the counter as sub, and the list here is subdoms, which is the items in the subdomains file splitted line by line. Next, in the for loop, we start to ping the target. So how do we ping the target, or how do we make sure that the subdomain exists? First, as you can see, we use the protocol HTTP, and we create an actual request. In that, we pass in the value of the counter in the for loop, sub. The value of the counter, sub, in the for loop equals to the subdomains found in the list here. So since we are iterating line by line, we're going to be able to use or have a shot at every single potential subdomain. So sub here could be any word in the subdomains file. Dot, we use a dot, okay, and next we use sysarg because we want to take the value of the domain as an input from the user. So when you run the script, you're going to have to provide the domain name or the IP address that is your target. So here we use one argument. The script here takes one argument. So once the user provides the argument before running the script, it's actually passed here. So the end result will be a complete HTTP request with the subdomain dot the given domain. Now, based on the outcome of this request, we store the outcome or the response in a variable named sub_domains. Okay, next we use try and except, because at the end, how do we know that the subdomain that we are actually pinging is, or actually does exist. We find out using the response we get. So here we send a GET request, and based on the response, we know if this is a valid subdomain. So basically, if we get 404, it means that the subdomain is not valid. So how do we know all of that? We use try and accept. And if there is no error in the connection based on the try and accept, we conclude that the actual request we have just sent actually returns 200 as a response code, which means that the subdomain or the line we have actually iterated through in the subdomains list is correct. Once we do that, we catch the last request or the last valid request and print it out. Okay, what other protocol could be used for subdomain enumeration? In the script here, we used HTTP to ping the subdomains using the browser. But on the other hand, we can just do that fine with other protocols such as DNS. What function does Python use to get the input from the command line? It was just there, the sys argument. All right, let's have a look at this. So now subdomain, if we run this, and the input we provide is the IP address of the target. Let's see. Now here, this means that this address or the target doesn't have valid subdomains based on our word list. It could be two things, one of two things. It's either that the target doesn't have subdomains, or that the word list that we have used in the code doesn't have the correct matches or doesn't have the correct keywords to match the subdomains. Anyway, let's now go over task 3. In task 3, we use a directory enumeration script. So directory enumeration is a method to enumerate files and directories on a web server. It's part of the reconnaissance phase of a penetration testing engagement. Let's go over the code here. So in the first two lines, we import the necessary libraries, and then we define the word list using open, and we iterate through the word list using read mode. Then we split the lines so that we have the correct word list in the correct format, line by line. And next we use a for loop. In the for loop, we use dir as the counter or the iterator, and directories as the file that we are iterating through. Directories contains the items in the word list, line by line. Directory enumeration is the new variable that we define. It's where we actually try to navigate using the protocol HTTP. And here we have input taken by the user. The input taken by the user here is the domain that we are enumerating, /dir.html. So here we plug in the value from the word list and then followed by .html, indicating that we're trying to form a complete request to a directory on the web server or the target web server. This will be, let's say, example.com/index.html. That's an example. Next, we store the outcome in the directory underscore enumeration. Next, we want to examine the request details. So we use requests.get, and we store the outcome in the variable r. And then if the status code equals to 404, we pass, it means that the directory doesn't exist, or the item dir that indicates a directory, it doesn't exist on the target. If it doesn't return 404, it either returns 200 or 301, which means that the directory does exist. So we say valid directory, and we print out the valid directory that we have actually used here in this line. Let's have a shot at this. So I have copied the script into this file. So I'm gonna directly use Python 3, directory enumeration, followed by the target. Remember that we have to supply the target as an input. As you can see, we have discovered 4 directories, or 4 files: index, Apollo, private, surfer. Now, Apollo gives us this hash. Users, we have users and their passwords. And still we have this, private. Okay, the private here looks like a sign-in area. Anyway, let's go back and answer the questions. How many directories can your script identify on the target system? It is 4. What is the location of the login page? It is private. Where did you find a cryptic hash? It's under Apollo. And where are the usernames located? It is under server. And what is the password assigned to Rabbit? In the server page, we can see the passwords assigned for every single user, including Rabbit. Okay, in the next task, we have a script that actually scan a network. So it's a network scanner. Note here that the script uses the ARP or ARP protocol instead of ICMP because usually ICMP is blocked. Okay, that's why to scan networks, it's preferable to use the ARP protocol if you are using Python. Let's go over the script. So first we import Scapy, or we use the Scapy library, and we import all the methods from the library. The Scapy is actually a network or a Python library that allows you to perform various networking functions to send and receive packets. Next, we define the necessary variables. Since we are scanning a network to detect live hosts, we can have to specify the interface we are using to scan the network, the IP range, the network IP address, okay, and the broadcast MAC address. Since we will be using ARP to send ARP requests or ARP packets, we will need to define the broadcast MAC, and then simply you can just directly use the script. If you want to scan the network, all you have to do is just to replace the IP range with the IP range you have, the interface, and the broadcast MAC address. These are the variables you can play with depending on the scenario that you've got. And then you can just leave everything as is and scan the network. This will give you the live hosts on the network as seen in the output here. We're not going to run the script in the attacker box here because it's going to take some time, and we already have the output here, and the script is clear and easy to understand. What module was used to create the ARP request packets? It's Scapy. This is the network library or the Python library that's used to send packets. Which variable would you need to change according to your local IP block? If I want to scan a different network, you have to change the IP range variable. What variable would you change to run this code on a system with the network interface, ENC33? You have to change the network interface by changing the value of the variable interface from here, from Ethernet 0 into ENC33. Right, port scanner. Right, so in the port scanner, the first thing I did is to copy the script, have it over the attacker box, and then before I run this, I'm going to go over the script. Let's go up. So here we import the necessary libraries again. So import system to the system functions socket. Socket is a Python library used to perform networking functions. And then we have this library that's used to create banners. So this is the banner. It's not important when it comes to port scanning. Next, we define the IP address that we want to scan to detect the open ports. And then we have an array defined. It's an empty array. This empty array will be used to populate the detected open ports. Then we have the port range. This is the range that we will be scanning. You can make this range way less if you define what are the ports you want to scan. Instead of range, you could just use an array or a dictionary or a list. So this list here contains the ports that will be scanned. If you know what to scan, use a list with the ports defined. If you don't know what to scan, you want to scan everything, you just use the range function. Next, we have a function, probe port. This is the function that we'll be using to detect if a port is open. So what we do actually, we use the socket function here to detect the open ports. So if you connect to the IP address on the given port from the range here, and if we get a proper response, it means that the port is open. If we don't get a response back, it means that the port is not open. And this is all controlled using the variable result. If result equals to 0, then we have a port. Next, we have a for loop. In the for loop, we iterate through every single port found in the ports variable. And for every single port, we call the function probe port. In the probe port, we pass in the IP address and the port from the for loop. And we connect. If there is a connection, based on the outcome or based on the value of the result, we know that the port is open. And if the port is open, if the result value or the result variable equals to 0, we actually append the port to the list of the open ports. Open ports is defined here using an empty array. And then if open ports, we use a if statement here to see if we get any open ports, we print them out. If we don't, you just say looks like no ports are open. So having this copied over here, don't forget to change the IP address given here with the IP address of the machine that we have here. And let's run. So we run the script. Right, let's leave this running, answer the questions. What protocol will most likely be using TCP port 22? This is straightforward, it is SSH. What module do we import to be able to use sockets? It is the socket module. What function is likely to fail if we did not import the system library? It is the flush function, which is used to flush the buffer. Now, this function is part of the system library. Anything you want to do with the system, just import the system library. Let's go back and see if the ports are detected. We have 3 open ports, 22, 80, and 2100. So how many ports? We've got 3 ports. What is the highest port number open on the target system? It is 2100. Let's talk about file downloader, task 6. Here we learn how to download files using a Python script. Now, this can be achieved by just importing the necessary libraries. When we want to download files, we use the requests library or the request module. Then we define the URL. The URL should point to the downloaded file or the file to be downloaded. In our case here, it is a zip file, or in the above script here, it is a PNG file. Next, we create a variable named R. In here, we actually send the request or connect to the target site using request.get method. We define the URL and we follow the redirects. And then after we connect to the URL here, we should be retrieving, or we're supposed to retrieve the zip file. Therefore, we open the file or we store the file using the write method. Previously, we learned how to read files using the read method. Here we're using WP to read files. Alright, so what's the function used to connect to the target site? It is requests.get. And what step of the unified cyber kill chain can psexec be used? Actually, it is a lateral movement, because as can be seen here, psexec is used to allow system administrators to run commands on remote systems. Now, when it comes to when attackers get access to a system, they actually try to invoke psexec to run commands on another system. That's why we call it lateral movement. Alright, I'm going to skip task 7. I'm going to do it after task 8. In task 8, we actually do keyloggers. Keyloggers can be created in Python using 2 libraries. The first one is keyboard. It's a library that's used to record keystrokes, or it can be used by using another library called pineput. So in pineput, we can actually record keystrokes based on certain criteria. In the example script here, you can see that we define a function that records keystrokes. So whenever a key is pressed, we start the keylogging process. And when another key is pressed, we actually release the logging process. So in our case here, the onRelease function, it is when we define the escape as a trigger to stop the process of key logging. So in the example here, we use the pineput library. And in the pineput library, we have 2 functions. One is for creating, or one is for logging the keystrokes, and another one is for stopping the logging process. On the other hand, using the keyboard library, as can be seen here, we can use the keyboard module. In the keyboard module, we start the key logging process until the user presses enter. When the user presses enter, we stop the key logging process, and then we play the keys or we print them back. What package installer was used? It is pip3. And what line in this code would you change to stop the result from being printed on the screen? We change this keyboard.playKeys. We remove it all together if you want to remove, or if you want to stop the logged keystrokes from being printed back on the screen. Now let's go back to hash cracker or task 7. So to create a Python script that crack hashes, you're going to have to use one of the most popular hash libraries in Python. It is hashlib. Anything that has to do with hash cracking or hashes, it must be done using the hashlib. Even if your script does not crack hashes, even if you want to convert a single string into an MD5 or an SHA, you're going to have to use the hashlib. Let's go over the script. In this script, we define first a variable named word location. In this variable, we store the path or the file that will be used as a word list. Next, we define another variable called hash input. This is where we retrieve the hash that we want to crack. In this case, we actually retrieve it from the user using the input function, same as the word list. Now, what's the function here, or what's the objective of the word list? The word list is a file that contains possible passwords or possible plain text matches to the hash. These are in string format. This is not a hash word list. This is a word list of text strings. Later down the road, when we iterate through every single line in this word list, what we do here, we convert every single line or every single string into an MD5. How do we do that? Using hashlib.md5, we convert every single line from the word list into the corresponding MD5 hash. We store this in a variable named hash, and then after we have the string hashed into MD5, we compare it to the given one. Here we compare this. Now, what's the objective of hex digest that we applied on the MD5? It's actually to properly form this into MD5 hex, because the actual MD5 representation is way big. That's why we use hex digest to properly format the hash in hexadecimal. And then after we have the strings in the word list converted into MD5, we compare them to the given hash in the input. If they match, then we know that we have a match in the word list, and we sent out the original password or the original string to the terminal. Now we're gonna have to copy this. Okay, so nano hash cracker. Okay, all right, let's see the hash that we want to crack. What is the hash you found during directory enumeration? First, we're gonna have to see what is the hash we want to crack. This is the hash that we're gonna crack, and the word list that we're going to use is located under which directory? Let's see here. The word list location. It is home. No, not this one. It's actually given in the, I remember it was given here in the intro. User share word list Python for pentesters word list 2. Okay. Okay, so first let's have the hash over. Copied, and we run this. Enter word list file location. Next, we have the hash to be cracked. No such file or directory. Let's have a look at this file. Looks like we have provided the word list path with a space here. We're gonna have to cancel this. Just make sure to copy the location without any spaces. The hash to be cracked. And we've got no matches. All right, let's see why. What is the hash we found during directory enumeration? Looks like it is telling us to go back to task 3 and retrieve the hash we found. So there was a hash here somewhere. Where did you find a cryptic hash? It was Apple. All right, so if you remember, we found the hash there. So if you still have the hash, just paste it here. What is the clear text value of this hash? Okay, we're gonna go back to the terminal and relaunch the cracker. Supply the word list location. And next we supply the hash we found during directory enumeration. And we found a clear text match. It is rainbow. Gonna have to copy this. Probably we're gonna answer this. What's the clear text value of this hash? Modify the script to work with SHA-256 hashes. Using the modified script to find the clear text value of this. All right, going back to the script now, nano hash cracker. And we have to modify this to work with SHA-256 hashes. So here, just scroll down and replace MD5 with SHA-256. Rerun the script. Supply the word list location, the same one we used previously. And now the hash is this. And the password for this hash is Red Wings. And lastly, in task 9, we are brute forcing SSH credentials. All right, so let's dig directly here to the script. The first thing we do here is to import the necessary libraries. We have Paramico, the Python library that's used to connect to SSH servers. It actually replaces sockets. If you import Paramico, you don't need to use socket to connect to the server. And then we import sys and os to interact with files. Next, we define the target username and password. They're all given by the user. The target is the IP address of the SSH server. It's given by you. The username is the username you want to find the password for. This also should be supplied by the user. The script here assumes that you know what is the user you want to brute force. Okay. And next, the password file. This is the word list that we're going to need to supply. This is the function that does all the work. Let's leave this at the end and start with this. So here we open the password file in read mode. Okay, we read through every line and we store the we store them in the password variable, and then we call the SSH connect function and we supply the password from the file. So for every line read in the file, we have a password. The password is then passed as an argument, as a parameter to the SSH connect. In SSH connect here, we define we have the parameter password that has been passed from the password file, and code 0. The code 0 here is it's like a indication whether the connection to the SSH server is successful or not. Paramico uses code 0 to indicate a successful connection and code 1 to indicate a failed connection. Okay, so here we are passing a password. We pass this password to SSH connect, and then we connect to the SSH server using the password. The password, the username, the port, and the target. SSH.connect, that's where it goes. Now what happens if the code equals to 0, we have a successful connection. Except here we handle the failed connection if the code equals to 1. And we close the connection. Lastly, we return the value of code. So what happens here, the code will be either 0 or 1. We said earlier that Paramico returns 0 if the connection was successful. Now imagine that when you connect to the SSH server and the response of the code or the response was 0, it means that the password that we used or we passed earlier in the function call was correct. So this means that when we go back here to the if statement and we resume the code, if response equal to 0, the response here is the variable that holds the value returned by the SSH_connect function. So if the code equals to 0, it means that we have a successful connection. So if response equals to 0, we know that the password we supplied earlier and was passed to the function was correct. If not, we say that there is no luck and the password is false. That's how the code works. Now, having the code copied over to the machine, we need to apply this to the username Tiffany that we have discovered earlier from task 2 or task 3 directory enumeration. Let's run this code. Enter the target IP address. The IP address is the IP address of the machine here, so pass this here. And next we have enter the username to brute force. The username is given, it is Tiffany. And enter the location of the password file. It is the location of the word list given earlier in the task. Okay, now the brute force process starts. And it says no luck. So no luck here is printed out every time a password is attempted against the target and fails. At the end, we found the password. Trust no one. So what is the SSH password of this user? It is trust no one. And what is the content of the flag? All right, having retrieved the password now, it's time to connect. So SSH Tiffany at. We copy the target IP address and have the password copied as well. So now we connect to the target server. Let's see where we are under Tiffany ls, and we got the flag. Okay, so guys, that was it.